When did the universe begin? 13.8 billion years ago. The Big Bang. Everyone knows this. Wrong. Here's what nobody tells you. The Big Bang didn't happen at the start of anything, because there was no start. The word start requires time. And time? Time didn't exist yet. That belief is not a little wrong, fundamentally wrong. Let me give you a fact that should stop you cold. A photon of light that left a distant star 8 billion years ago? From that photon's perspective, no time passed. None. Zero. The journey that took 8 billion years on your calendar took exactly 0 seconds for light itself. Light doesn't experience time. And here's why that breaks everything you think about the Big Bang. If light doesn't experience time, then the moment of creation and this exact moment, right now, you watching this, are the same moment. From light's point of view, the universe didn't begin at a point in time. It began at the point where time stops making sense. This changes how you understand existence itself. Not just physics, not just cosmology, your relationship with reality. Let me show you. Pull out your phone right now. Turn on the flashlight. Point it at the wall. Simple. Obvious. You've done this 1,000 times. But here's what you've never considered. The light leaving your phone right now is traveling at exactly 299,792,458 meters per second. Not approximately, exactly. That number isn't a measurement, it's a law, a cosmic speed limit that nothing with mass can ever reach. And here's the strange part. That light hitting your wall, it experiences no time whatsoever. The photons leaving your flashlight and the photons hitting the wall exist in what physicists call a null interval. For you, there's a before and after. Light leaves, light arrives. A tiny fraction of a second passes. For the light itself, those two events are the same event, meaningless. That word, time, becomes meaningless when you travel at light speed. People say light travels fast, but that's just a label. Light doesn't travel fast. Light travels at the speed where time stops existing. There's no fast, there's no slow, there's just the boundary where the rules change. Do this right now. Keep your flashlight on. Watch the beam hit the wall. Now think about what's actually happening between your phone and that surface. From your perspective, light is crossing maybe 2 meters of space in a tiny sliver of time. From the light's perspective, your phone and the wall are touching. There's no gap, no distance, no duration. Wild. This isn't poetry. This isn't metaphor. This is what Einstein's equations demand. The universe keeps strict books, and the accounting says the faster something moves, the slower its clock ticks relative to everything else. This is time dilation. You've heard the term, but most people treat it like a curiosity, a weird fact for trivia night. It's not trivia. It's the architecture of reality. At everyday speeds, you walking, cars driving, planes flying, the effect is so tiny it's invisible. Billionths of a second. You don't notice. But at speeds approaching light, the effect dominates. Clocks slow dramatically. Time stretches like taffy. And at light speed itself, the clock stops. No ticking, no duration, no before or after. So when scientists talk about light traveling from the edge of the observable universe, taking billions of years to reach us, they're describing our experience, our clocks, our calendars. From the light's perspective, the edge of the universe and your eyeball are the same location at the same moment. This isn't preference, it's accounting. And here's the part that should make your brain itch. If light doesn't experience time, what does that mean for the moment of the Big Bang? Hold that thought. Let's break this down. Why does time slow when you move faster? This isn't magic. It's not a glitch. It's geometry. But not the geometry you learned in school. Forget flat surfaces. Forget rulers and protractors. We're talking about spacetime, a fabric a single thing that combines the three dimensions you can see with one dimension you can only feel: time. Here's the part nobody tells you. You're always moving through space-time. Always. Even when you're sitting perfectly still, doing nothing, watching this video. Right now, you're moving through time at maximum speed. Your clock is ticking as fast as it possibly can, because you're not moving through space. But here's the trade-off. The universe has a budget, a strict one. Your total speed through space-time is fixed, constant, unchangeable. You can spend that speed moving through space, or you can spend it moving through time, but you cannot exceed the budget. This is the cosmic speed limit, and it's enforced absolutely. Think of it like this. Imagine you have exactly 100 units of motion. Right now, sitting still, all 100 units go toward moving through time. Your clock ticks at full speed. Now start walking. Some of those units shift from time to space. Maybe 95 units for time, 5 for space. Your clock slows down, slightly, invisibly, but it slows. Now get in a car. More units shift, 90 for time, 10 for space. Now board a rocket, push toward light speed, 50-50, 30-70, 10-90. Your clock is crawling now. And at light speed, all 100 units go to space, 0 units left for time. Your clock stops completely. Light doesn't negotiate. It can't. It has no mass. It's forced to spend every unit of motion on space. Nothing remains for time. This is why photons don't age. They can't. The universe's accounting doesn't allow it. Beautiful. And brutal. People say time dilation is Einstein's theory, but that's just a label. It's not a theory anymore. It's been measured, tested, confirmed with atomic clocks on airplanes, satellites, particle accelerators. The books always balance. Now zoom out. Think about what this means for the universe itself. When astronomers say light from a distant galaxy took 12 billion years to reach us, they're using our reference frame, our clocks, our experience of duration. From the photons' reference frame, that journey took 0 time, literally 0. Not almost 0, not effectively 0, mathematically, physically, absolutely 0. The photon left that galaxy and arrived at your eye in the same instant. Here's where your intuition fails. From light's perspective, the entire universe, every point in space, every moment in time, exists simultaneously. There's no sequence, no before, no after, just existence. So far we've learned time isn't fixed. It bends, it stretches. It depends entirely on how fast you're moving. And at light speed, it vanishes completely. Now here's the question that should haunt you. If time behaves like this, if it's flexible, relative, speed-dependent, then what was happening before the Big Bang? What does before even mean when time itself is part of the system that got created? This is where a 16-year-old kid in Switzerland started asking dangerous questions. His name was Albert Einstein. 1896. A teenager in Aarau, Switzerland is daydreaming during class. Not about girls, not about sports, about light. He asks himself a strange question. What would happen if I chased a beam of light? What if I ran beside it at the same speed? What would I see? This question consumed him. Think about it. You're running next to a light wave, matching its speed perfectly. From your perspective, the wave should appear frozen, stationary, like a photograph of a ripple that never moves. But here's the problem. Maxwell's equations, the laws governing light and electricity, don't allow for frozen light. They don't permit a stationary electromagnetic wave. The math breaks. The physics collapses. Wait, something was wrong. Either Maxwell was wrong, or something deeper was broken. For 9 years, this puzzle tortured Einstein. He wasn't famous yet. He wasn't a professor. He was a patent clerk in Bern, a nobody, reviewing other people's inventions by day thinking about light by night. And then, in 1905, the answer hit him. Quiet. It wasn't about light being special. It was about light revealing something fundamental. You can never catch up to light. Not because you're too slow, not because your rocket isn't powerful enough, but because the universe restructures itself to prevent it. Here's what Einstein realized. If you speed up to chase light, your clock slows down, your rulers shrink. Time and space literally warp to ensure that light always passes you at exactly the same speed, no matter how fast you go. This isn't preference, this is law. The speed of light isn't just a speed, it's a conversion factor, a cosmic constant that tells space and time how to trade off against each other. Einstein called it special relativity. People say it's just a theory, but that's just a label. It's the most tested framework in physics history. Every GPS satellite, every particle accelerator, every atomic clock confirms it. The constant is enforced. Now here's where it gets uncomfortable. Einstein's insight didn't just explain light, it demolished our understanding of time. Before 1905, everyone assumed time was universal, absolute. A cosmic clock ticking the same for everyone, everywhere. Wrong. Time is personal, local, dependent on your motion through space. Your now and my now are only the same if we're standing still together. Start moving and our nows drift apart. This terrified physicists. But Einstein wasn't done. 10 years later, he extended the idea. General relativity. Gravity bends spacetime too. Mass warps the fabric. Time runs slower near heavy objects. And when you take these ideas to their extreme, maximum gravity, maximum density, the moment of the Big Bang itself, something terrifying happens. The equations break. Time stops being time. Space stops being space. The framework that lets us say before and after dissolves. And this is where the Big Bang gets weird. Because if time itself was created in the Big Bang, asking what happened before is like asking what's north of the North Pole. The question doesn't work. Let's make this concrete. Two twins, identical, born the same moment, same DNA, same starting clock. One stays on Earth, the other boards a rocket. The traveling twin accelerates to 90% of light speed. She flies to a distant star, turns around, flies back home. From her perspective, the journey takes 10 years. She steps off the rocket, hugs her brother, except her brother is old, gray hair, wrinkled skin. 40 years have passed on Earth. She's aged 10 years. He's aged 40. Same universe, same reality, different clocks. Dangerous. This isn't science fiction. This isn't a thought experiment that stays on paper. This is what the math demands, and the math has been tested. People say the twin paradox is theoretical, but that's just a label. We've measured it. In 1971, physicists put atomic clocks on commercial airplanes, flew them around the world, compared them to clocks on the ground. The flying clocks lost time, exactly as Einstein predicted. Billionths of a second, tiny, but real. The universe keeps receipts. Now scale this up. Particle accelerators smash protons together at 99.99% of light speed. At those speeds, unstable particles that should decay in microseconds survive for measurable stretches. Their internal clocks are running slow. We watch them live longer because time itself bends for them. This is where your intuition betrays you. You want time to be fair, universal, democratic. It's not. Time is local, personal, speed-dependent, and at light speed, it vanishes entirely. So far we've learned, Einstein's insight wasn't abstract. It's measured, tested, proven with clocks, particles, and satellites. Time dilation is real. Now here's the part that matters. Every piece of technology that touches your daily life, Every smartphone, every navigation system depends on understanding this. Because if we ignored time dilation, your GPS would drift by kilometers within hours. And GPS engineers don't ignore it. They account for every nanosecond. Because reality doesn't issue refunds. Open your phone. Open any map app. Watch that little blue dot find you. Accurate to 3 meters, maybe less. Simple. Except it's not simple. It's Einstein, running invisibly in your pocket. Here's how GPS actually works. 31 satellites orbit Earth. Each one carries an atomic clock, precise to billionths of a second. These satellites constantly broadcast their position and their time. Your phone receives signals from at least 4 satellites. It compares their timestamps, calculates how long each signal took to arrive, triangulates your position. Simple geometry, basic math. Except, those satellites are moving at 14,000 kilometers per hour, fast enough that their clocks tick slower than clocks on Earth. Time dilation. But wait, there's another effect. Those satellites orbit 20,000 kilometers above Earth's surface. Up there, gravity is weaker. And weaker gravity means time runs faster. 2 effects, opposite directions. The speed effect slows their clocks by about 7 microseconds per day. The gravity effect speeds their clocks by about 45 microseconds per day. Net result? Satellite clocks gain 38 microseconds every single day. Look, 38 microseconds sounds tiny, ignorable, background noise. Wrong. Light travels 300 meters in 1 microsecond. 38 microseconds means 11 kilometers of error per day. Within a week, your GPS would be useless, telling you you're in the wrong city, the wrong country. This isn't preference. This is physics. So GPS engineers pre-program the satellites. They adjust the clocks before launch. They make them tick slightly slower on Earth, so they'll tick correctly in orbit. Einstein's equations run in your pocket every single day. Here's the part that should hit you. You've used GPS 1,000 times. Never once thought about relativity. Never once considered that your phone is compensating for the bending of time. But it is. Every navigation, every delivery, every ride-share pickup built on space-time curvature. The universe doesn't care if you understand. The books still balance. And now here's a question. If time bends measurably around Earth, what happens at the edge of the universe, at the beginning of everything? Do this right now. If you have an old television, one with an antenna, turn it on. Find a channel with no signal, just static, noise, snow. Watch that fuzz. About 1% of that static isn't random. It's ancient light, light from the beginning. You're literally watching the Big Bang. Exact. In 1965, 2 engineers at Bell Labs were building a radio antenna. Arno Penzias and Robert Wilson. They kept detecting a strange hum, a background noise they couldn't eliminate. They thought it was pigeon droppings. Seriously. They cleaned the antenna, rebuilt parts of it. The noise persisted. Everywhere they pointed, every direction, same signal. Finally, they realized this wasn't noise. This was the oldest light in the universe. Light released when the cosmos was only 380,000 years old. Light that had been traveling for 13.8 billion years to reach their antenna. The cosmic microwave background. Here's what makes this mind-bending. This light started its journey when the universe was a hot plasma, dense, opaque, glowing. Then the universe cooled, became transparent, and this light was released, free to travel. For 13.8 billion years, it's been crossing space, stretching as the universe expands, cooling from visible glow to faint microwave radiation. And now it's everywhere, in every direction, filling all of space. Here's the part that breaks your brain. From our perspective, this light traveled for billions of years. From the light's perspective, 0 time, 0 duration. Those photons hitting radio telescopes today are, from their own reference frame, still at the moment of release. The beginning of the transparent universe and right now are the same instant for light. People say we're looking back in time, but that's just a label. We're not looking back. We're receiving signals that never experienced forward. The universe keeps strict books, and light's ledger shows no time elapsed, ever. Now here's where it gets even stranger. If we trace this light backward, past the moment of release, past the plasma era, toward the Big Bang itself, we approach a boundary. Not a boundary in space, a boundary in time, a point where temperature becomes infinite, density becomes infinite, and our equations stop working. This is the singularity. And here's the truth. The Big Bang didn't happen at a moment in time. It happened at the place where time stops being real. Stop. Let me say that again. The Big Bang didn't happen at the start of time. It happened at the boundary where time itself loses meaning. This isn't wordplay. This isn't philosophical games. This is what the physics demands. Here's the part your teachers skipped. When we talk about the moment of the Big Bang, we're using everyday language. Before, after, first, then. Words designed for human experience. Words that assume time already exists. But at the singularity, time doesn't exist yet. There's no clock, no duration, no sequence. Asking what happened before the Big Bang is like asking what's south of the South Pole. The question contains its own impossibility. Quiet. Let that land. People say the universe began, but that's just a label. Beginning implies a moment, a starting gun, a first tick of a clock. But the clock itself emerged from the Big Bang. Time is inside the system, not outside it. Think about what just happened. Your entire framework for understanding existence, past, present, future, only applies after a certain threshold. Before that threshold, those words point at nothing. The universe doesn't negotiate with human intuition. Here's the deep truth. The Big Bang isn't an event that happened in time. It's the event that created time. It's not a moment you can point to on a timeline. It's the reason timelines exist. This is where physics becomes philosophy, and philosophy becomes vertigo. Now zoom back to light. Remember, photons don't experience time. From light's perspective, the entire history of the universe, all 13.8 billion years, happens instantaneously. Creation and destruction, birth and death, the Big Bang and this exact moment. Same instant. For light. So here's the reframe that should shatter your assumptions. You've been thinking about the Big Bang as something ancient, distant, long ago. Wrong. From light's perspective, the Big Bang is happening now, has always been happening, will always be happening. There is no long ago for photons. The universe isn't old. The universe is simultaneous. Only your slow, massive, time-bound experience makes it feel like history. Reality doesn't issue refunds on this truth. So when you see starlight tonight, light from millions of years away, remember, that light isn't old. That light is ageless, and so is the Big Bang that started its journey. Now here's the part that should terrify you. Follow this carefully. You exist in time. You have mass. You move through space-time at a fixed budget. Part space, part time, always trading. Light doesn't trade. Light spends everything on space, nothing on time. For light, all of space-time is flat, compressed, simultaneous. Here's what this implies. The photon that left the cosmic microwave background, that ancient glow from the early universe, is still, from its own perspective, at the moment of emission, and also, simultaneously, at the moment it strikes your eye. No journey, no travel, no duration. Now push further. That same photon's origin traces back toward the Big Bang, toward the singularity, toward the boundary where time breaks down. From the photon's reference frame, that boundary and your eyeball exist in the same moment. Read that again. The Big Bang, right now, same moment, for light. Wild. You are directly connected to the origin of everything. Not through history, not through a chain of causes stretching backward, through the timeless fabric of light itself. This isn't metaphor. This isn't spiritual poetry dressed in physics language. This is geometry. The geometry of spacetime says light connects all points without duration. The birth of the cosmos and your Thursday afternoon exist on the same null interval. People say the universe is ancient, but that's just a label. Ancient is a time word, and time is perspective dependent. From your perspective, billions of years. From light's perspective, now. Always now. Only now. The constant is enforced without exception. So here's the question that should keep you awake. If the Big Bang is still happening from light's point of view, if creation is perpetually present in the timeless experience of photons, then what exactly are you? A process inside an instant, a ripple in something that never moves. Beautiful. So where does this leave you? You woke up today thinking the Big Bang was ancient history, a moment buried in the distant past, 13.8 billion years gone. Now you know. That's your perspective. Your clock. Your slow, massive, time-bound experience. Light tells a different story. For photons, the universe is eternal and instantaneous. All moments collapsed into one. The beginning and the end sharing the same breath. You're not separate from the Big Bang. You're inside it, still, always. The universe doesn't keep separate books for past and present. It keeps one ledger, one accounting, and light reads that ledger without time. So tonight, when darkness falls, step outside, look up. Every photon hitting your eye has traveled without experiencing a single moment. Stars that exploded before Earth existed, galaxies spinning at the edge of everything. Their light arrives ageless, timeless, still carrying the signature of a cosmos that never grew old. You asked when the universe began? The answer isn't a number. The answer is that when is the wrong word. Time is inside the story, not outside it. And light is the narrator that never ages. Now here's my question for you. If light doesn't experience time, and you're made of atoms forged in stars, held together by electromagnetic forces carried by photons, are you really as old as you think? Leave your answer below.